Good afternoon and welcome to R2A's webinar on project governance and SFAIRP. I'm Gay Francis and this is my business partner Richard Robinson. So as an introduction, as many of you know, Richard and I are career risk and due diligence engineers and have been working together for over 25 years at R2A and promoting the use and value of the SFAIRP approach for over 20 years. This has always been based on the common law duty of care and now WHS legislation. However, it can be very effectively applied to projects as well. At a major projects conference in 2014, which Richard and I presented at, it was said that most major projects in Australia are over $60 million go more than 30% over time and budget. This is absolutely extraordinary and appears still to be the case if you listen to some of the reports in the news. Interestingly, one of the most common difficulties across projects seems to rest around the exclusive reliance on the risk management standard ISO 31000 as the basis to manage project risk and the use of Monte Carlo simulation, which predicts the most likely project outcomes. Whilst this is not wrong, it does miss the low probability, high consequence outcomes, i.e. the project showstoppers. For many years now, we've also been applying the SFAIRP principle to projects to ensure project showstoppers are eliminated and all other project risks are managed SFAIRP. So that's the basis of our presentation today, and over to you, Richard.
Thanks, Gay. I think you meant $600 million for major projects to go over time and budget rather than 60.
Thank you for that correction.
No problem. Here's the plan. Gay's already explained why we're doing it. As major projects just going so much over time and over $600 million, so many of them going over time and budget. The focus is on critical issues in this presentation, those ones that result in reputational damage to large organisations, major financial loss, and where that loss is large enough, and particularly with private investors involved, you can get potential legal action arising. We'll talk about the judicial interpretation of the hierarchy of control, which actually is fairly precise because it actually applies for as a defence against negligence, which therefore both works for any sort of negligence, whether that be commercial or safety, and that's where the SFAIRP business comes in. It's just another way of redefining it, so far as we can tell. And then the last little bit we'll talk about is how this integrates into the corporate risk systems. As Gay said, ask questions and type around the box. She'll monitor that and respond to any. And if she needs to, she'll break in to answer the question, particularly at the right time in the presentation. Now, this SFAIRP business, it's really defined by the common law. So far as we can tell, it's really quite extraordinary, and it pops up a bit later, particularly in its decision by Justice Mason. And the lawyers tend to refer to it as the calculus of negligence. And it applies to safety and it applies to any other commercial loss that may have occurred or commercial damage loss that may have occurred as well. Now, the four tests of negligence when you're acting as an expert witness, which is what R2A does reasonably frequently, was the event reasonably foreseeable? Is there a causal link between what was failed to be done and what the outcome and the consequence and the damage might have been? Was it preventable? And was the preventability of these things reasonable in all the circumstances that the decision was made? And if the answer is yes, then negligence typically arises. It's presently applied in safety law, obviously under the WHS legislation and the OHS Act in Victoria. And what we've sort of found quite curious is that you see the old calculus of negligence is defined in particularly the case law, which is more focused at safety. But in Victoria, when you looked at some of the decisions made by our judiciary here, they'd actually use that principle to, for example, decide to whether chop down old growth forests in Gippsland, which was a bit of a surprise to some of us as engineers, just looking at what the judiciary actually does. So the principle has been popped around all over the place. Now, some of you might have seen this slide before because we sometimes use it for the health and safety stuff. But the point it's trying to make is that for any particular thing that you do, whether it be a business or a project or whatever, there's a whole lot of things that can go wrong. There's an absolute pot full of these things. The trick is, of course, there's only some that are really critical. And it's those critical ones that tend to blow projects out and give you that 30% overrun in time and budget and perhaps hurt somebody. And they're the ones that you really have to focus on. And it's only those ones that would ever boil over into the judicial zone, as it were, and be subject to judicial scrutiny and therefore to the common law and therefore the way things are panned out in the new language, SFAIRP. This session's basically about project due diligence. And one of the things we keep having to make the point, because we keep coming across this at all sorts of places at all sorts of times, and it is one of the reasons why ISO 31000, the risk management standard, doesn't seem to work, and it causes the greatest confusion at senior decision-maker levels, is the fact that there are actually different types of risk out there. And just to try and apply the same technique to these different risk issues does not seem to work very well. For example, the one on the left here, okay, does my mouse show up at all? The one on the left, at least this is a plot of likelihood versus consequence, the one on the left in red, that's safety risk. It's all downside risk, the risk from which there's no prospect of gain. If it all goes wrong, everybody loses, there are no winners. The one on the right in blue is business risk, and that's normally assumed by the business people to be symmetrical about the mean, because you can buy shares in the stock market and the price can go up or the price can go down, as it currently is doing. And the more risk you take, the more reward you might get, and vice versa. The one in the middle is the one we're talking about today, because what typically happens with the project is that somebody makes a promise, we're going to do this thing, and when it's finished, it's going to deliver all these benefits. So what normally practically happens, the person implementing the project manager, is actually in the first instance doing a downside risk assessment from a promised upside risk position. And typically what happens just before the tender's released is a bunch of people turn up to do what's termed a value-added study, where they add a little bit of upside downside to that promised upside position. So in that purple line there, the dotted vertical line represents the promised upside position with a little bit of tweaking value-added study being thrown on top. Now that's the one we're focused on. And we quite literally have been in multi-million-dollar projects with multiple directors, and they've had specially imported risk managers from the UK. And after a couple of hours, because they kept pushing the blue one and we were pushing the purple one, the board just flung them out of the room. They just got sick of the whole thing. It is really a serious issue at most senior decision-making levels, and the idea that a single risk management technique can apply to everything is a little odd. Just to sort of make the point, here's the augmented SWOT process, which commercial people like, because it's got upside downside. And you can see there you've got threats, hit weaknesses, you get vulnerabilities, and the strengths hit opportunities, you get value addeds, SWOT being strengths, weaknesses, opportunities, and threats. Now, because we're talking about a promised upside risk position, we're not looking at the upside. That's already been built into whatever the project's supposed to achieve. So what we're basically doing is the downside, the threats, hitting weaknesses and creating vulnerabilities. So we're fretting about threats and vulnerabilities. This is basically the core to the approach. And what genuinely surprises us, and Gay and I have been doing this for a long time now for projects ranging from about 10 million to about 2.5 to $3 billion, and none of the projects we've had anything to do with have ever gone over time or budget. I think what rather depresses us is not as though we're doing anything which is new or novel. So far as we know, we're just adopting a very, very standard military intelligence technique, which is used by lots of other people in lots of other places, and it's not something special. It's the bit that really has us a bit stumped. But anyway, you can see here there's the four sort of arrowheads there, going from concept, scope, refinement, construction, operation, maintenance. And above that in orange is the project risk management. Now, in our experience, the way most people go about managing their projects is that somewhere during the scope refinement, a bunch of people who have suffered pain in previous projects get together and typically borrow a risk register from a previous nearest project and try to project into the future what might go wrong with this project. You can usually tell they've borrowed a risk register from another project, because if you're going through the register, you can usually find the name of the old project buried in there somewhere because somebody failed to do a global search and get rid of the damn thing. And what they do is try to guess as to the future what might go wrong. And there's a number of problems with that approach, not the least of which is the fact that this thing's usually got a whole risk register from the original project's got a whole lot of dross in it. Nobody's going to throw anything out, and people keep tweaking the damn thing, and it becomes an unwieldy and complicated thing. Typically what happens in that process too is as the project proceeds, somebody every now and then gets a bit of a panic and says, where's that risk register? We better have a look at it. But once it gets to practical completion, the commissioning stage there, that project risk register more or less gets set to one side, and the whole thing is handed over to the operation and maintenance people, who then have to fix up the things that didn't go quite properly with the project, and generally there's a fair bit of crankiness turning up at that point too. The alternative view is to do the one in red on the bottom, which is really just a standard military mission planning technique. So before you go on a military exercise, you're meant to declare what mission success looks like. So basically, a project's just another mission in life, and you basically have to decide before you start this thing, when you've got it in and working, as in you've projected yourself into the future, and the things that need to happen when it's actually operating and being properly maintained, not just practical completion, it's actually working and achieving all the things that you wanted to achieve. What are those things must it have got right in order for it to be declared a success? And they are the critical success outcomes. You sort of walked yourself into the future. Now, this is a very happy place because excellence awards are possible. Bonuses are possible. Promotions generally abound if it's gone well the first time. This normally you get this from the actual stakeholders. Gay has a sort of a slight irritation with the number of people we deal with in these things. It's the people who live or die by the result that have to define the critical success outcomes. They are the core stakeholders. There are a lot of interested parties who have a lot of opinions, but they're not the stakeholders. The stakeholders are the people who live or die by the result of the project. They are the people who have to define the critical success outcomes. You then step backwards from this happy place where you've declared what you must achieve in order for this thing to be a success, and ask the question of wherever you are in the project, whether it's in scope or construction or even operation and maintenance, what things threaten those critical success outcomes? And if any of those threats can affect one of those critical success outcomes, it becomes a vulnerability, which is the blue star. By definition, if you manage all those vulnerabilities, you will wind up in that happy place where everything worked the first time. We've never had it fail. I mean, you can say there's a number of other reasons why that's the case. One of the core reasons, so far as we can tell, if you really, really properly define the critical success outcomes, then you've actually described the prize. And if you can get everybody involved in the project clearly focused on what success looks like for that prize, generally it just lands better anyway. There's a number of other things we could say there, but I won't do it for this presentation. Now, just to sort of show you as a sort of a quick example, this is the sort of things we do for roads. This was done, something like this was done for Eastlink, and something like this was done for Marina Coastal Expressway, well, a whole lot of things actually. But basically, you do this sort of functional analysis, and the simplest way to do it is in a spreadsheet. You spell out across the top those things that you have to get right in order for the project to be a success. And then you spell out on the left-hand side those things which you think might threaten those critical success outcomes. And note that this thing here is a criticality analysis. It is not a risk analysis. It's not asking how likely these things are. At this point, it is merely asking if one of these threats manifests itself, how bad could the result be to that thing we're trying to achieve? And we normally do it 1, 2, and 3 X's. You can do it in lots of different ways. You've got to decide what works best for you. I do have a slide coming up describing what they are, but basically 3X is a potential showstopper. That means it's going to go over 30% of time and budget if you're talking about those particular success outcomes. 2Xs normally means it's something you want the tender to specifically address. So 1X means it's something that's drawn to the project manager. A dash means you thought about it but couldn't see how that threat could affect that vulnerability. And sometimes, even though you're not particularly looking for it, you might find a value added. So sometimes you might put that in there too. Gay did touch on this, and that's just being very careful at Monte Carlo. As we raise this because we keep coming across projects where people have done a Monte Carlo assessment and saying, we've done the risk assessment, everything's good. And you're looking at them going, no, that's not the case. As Gay said, the whole problem with the Monte Carlo assessment, I mean, what you do is basically spell out what you think the core factors might be in determining one of your critical success outcomes, and you put a probability distribution to those factors. In order to sum probability distributions to work out what the final cumulative distribution will be, you have to do a lot of statistical trials. And typically, the ones that I've seen, they probably do 15 to 20,000 trials to add these things up. Now, the difficulty with this approach, though, is that if you've got 3 rare things which have to conspire together to bring about a showstopper, say 1 in 1,000 chance for each one of those probability distributions, well, in order to find the cumulative 1 in 1,000 chance for each of those probability distributions, that's 1 in 1,000, 1 in 1,000, 1 in 1,000, you're going to have to do 1 billion trials. In fact, to be statistically significant, you're probably going to do 10 billion trials. So if you're only doing 15 or 20,000 trials, what happens to those low probability, the long tails in the input distributions? Well, the answer is they're ignored. They're just thrown away. Well, what does that mean? Well, that means the potential showstoppers will just be ignored by Monte Carlo simulation. It doesn't mean the Monte Carlo simulation is wrong, because what the Monte Carlo simulation will be telling you will be the most likely outcomes for the project, and that's got to be a good thing to know. I think that's one of the problems with this whole risk business. People seem to have this view that there's only one way to do risk, and they've settled on a particular technique or approach. But in fact, it's a multi-dimension thing, and you can cut it in a lot of different ways, and any one of those of which will give you insight, and none of them will be wrong. Well, the real point is it the one that's most useful in terms of what you're trying to achieve? And we're talking about preventing showstoppers. So we want to start over here with project due diligence, and here's me drawing the mouse with the grey circle rather than the yellow oblong that we've got, or oval that I've got there. The other thing that just pops up, and this sort of explains it, and we've seen this happen quite a lot too, and there's sort of a difference between the actual language that's used here. You see, have a look at the blue base to this thing. Suppose it's a large organisation, they've got 100 projects underway, and each one of those projects has a project manager in charge of it. Now, the likelihood of something horrible happening for any one of those projects, being blown out badly or somebody being critically hurt or something like that, is going to be low. Okay, just for the numbers to make the exercise, let's assume that the likelihood of it is 1 in 1,000 per project. Now have a look at the general manager who's sitting up there in the yellow box. Now, the general manager is probably going to be there at least for 5 years, and you've got 100 projects, each with a 1 in 1,000 chance of having something ordinary, like a showstopper, occurring to it. Well, from the point of view of the general manager, 100 in 1,000 is 1 in 10, and they're there for 5 years. So from their point of view, it's a 50-50 chance that something extraordinarily bad is going to happen to one of those projects during their term of office. So how do they feel about it? Well, the answer is they feel threatened. And so what do? Well, they create risk management policy. And then they send risk management policy minions to go out there and talk to each one of those project managers. And again, I've been that risk management policy minion on quite a lot of occasions. And you go out there and talk to these project managers with this big risk management policy stick, sort of saying, you will spend your scarce resources making sure this very rare thing won't happen, won't you? And you can see it in their eyes looking back at you. So I'm the project manager. I've got to get on with this thing. You know, I deal with the procurement issues, the staffing issues, the weather issues, all the other issues, and you want me to spend my scarce resources preventing what? And the point is, you see, they're both right. That's the tricky thing about this risk business. From the point of view of their individual project, something bad happening, sort of like 1 in 1,000 for the project, is low. And it almost certainly is not going to happen to them and their project. But from the point of view of the general manager, the cumulative effect of all these projects makes it almost certain. That's one of the reasons why top-down analyses are always threat-based and bottom-up analyses tend to be hazard and risk-based. It's top-down criticality-based and bottom-up hazard and risk-based. The language is actually different. And the trick is, so far as we can tell, they're both right. The point being, all senior decision makers assess a future uncertainty in the first instance based on criticality, not risk. You'll notice this with politicians. The minimisation of personal electoral liability is always logically prior to shareholder profits and taxpayer funds. If you suddenly wind up talking to a minister, you will find they are very, very risk-averse and risk-sensitive people. And if you put up a proposition which is likely to set them up for a fall, they will twitch instantly. I suspect it's one of the characteristics required of a competent politician. Perhaps I should just say one of the examples I typically give is Victoria's got a giant desal plant. It costs about $5.7 billion to build about 2010. Costs about $1.5 million a day, I think, to have there for the next 25 years. I think the Treasury prediction is about $18.5 billion in total. If you live in Victoria, you wonder why your water bill is so high. And in view of the floods at the moment, you speculate, why the hell do you need a desal plant? Well, the reason why it happens is because we had 10 years drought in Australia. It happened in a whole lot of capital cities. And if you come to a view that another 10 years drought is a credible possibility, and a major Australian population said it could actually run out of water, like happened in South Africa not so long ago, and you have the resources to make sure this thing cannot happen, what do? The answer is you build it. But if you did a risk analysis and asked the question of whether or not some water is going to fall in the mountains out to the east of Melbourne, and you could put water restrictions in and all these sorts of things, is the likelihood of running out of water, is that likely? The answer to the question is absolutely no. From a commercial viewpoint, it makes no sense from an upside-downside viewpoint. But from a criticality viewpoint and the possibility of actually running out of water, the answer is yes. So the decision was made, put it in. I can give you quite a lot of examples like that, but we really don't have time to go into it here. Now, I made the point this is all about top-down, and this is where the SFAIRP business becomes particularly useful. We find this V model we find what happens with most people and most project risk things, they're coming bottom up and get lost in the dross. Where if you come top down, you just hammer the thing stony dead in the first place. So you need your risk issues completeness argument in the first instance, and the quickest way to do that we've discovered is just do a threat and vulnerability table in Excel or numbers. You then sometimes have to go a little bit further into a zonal vulnerability analysis, because sometimes if some project's stretched out all over the place, you just can't define it functionally, you have to do other things. And you seldom go to detailed models, but if you have to, you would. But you try and keep the argument as high as you can. And the SFAIRP recommendations is basically saying, well, it's disproportional. Can we showstoppers have to be eliminated? And if you can't eliminate them, you're going to put every reasonable practical precaution you can. And if you still think that's all too tired and too tough, you just won't do the project. You have to stop it, which in safety terms, in the angle of the SFAIRP thing, would be prohibitively dangerous. Here's the basic process. We find that the best way to do it, and this is certainly the way we did it for Eastlink, we find the best way to do it is you go and do a first cut. In this case, go in and talk to a director for CETA, the government funding agency, Connect East, the company that's going to run it as a private enterprise PPP for the next 25 years, and Tish John Holland, who are building it. We were actually retained by Tish John Holland. And she got a first cut of a high-level vulnerability table from the three of the really competent directors who had all done this before and knew what they were talking about and what the critical success outcomes could be. And then we ran a project, a workshop with all the directors from all the companies using this vulnerability table, and they characterised the criticality into the first cut of the risk assessments. You then also have to sometimes do project zonal things, and roads are geographic things, so sometimes it's power lines and creeks and other particular geographic issues that need to be thought through. And then each one of the design disciplines, we have to go and talk to each of those. They keep doing their own risk review processes, but you make sure that those risk review processes are done in the context of these high-level delivery outcomes as decided by the overall managing group. And here's an example of the typical sort of thing that happens for a road. So I think I got muddled with the earlier slide there. We typically break it into two parts. I just don't know if you want to talk to this one at all, Gay, do you? But I'm happy to keep going. Okay, I'll keep going. We typically break it into two parts. There's the project performance critical success outcomes, which are those that the owner needs to have. And then there's the project delivery critical success outcomes, which is what the contractor wants to achieve. And you can see there, this is typical for a roadway. It's fit for purpose, improved travel times, connectivity. That's why you build roads. It has to be a maintainable asset over its design life. It has to deal with emergencies that could occur. It's got to be operationally safe. It can't create danger for people. It's got to protect the environment. And it's nice to have a good project reputation, although in Australia, we're less concerned about that sometimes, it seems. From the contractor's viewpoint, they want it delivered on time, to budget, to specification. They've got to maintain a level of road service for other road users during construction. They've got to make sure nobody gets hurt during construction, the environment. They can't go around contaminating the environment while they're building it either. Now, you'll see there that there's some pattern of blue X's there, 3 X's and blue X's there. And you'll notice that for those same threats, the pattern's different for the contractor, for the owner. And that's common. And the reason why this is important, if you're doing a large civil project that's going to take 5 years to build, and the contractor frets about the ones that they've got to worry about and ignores the ones that the owner might have, and they find out in the 4th year that the owner's got one that the contractor hadn't thought of, you can't fix it. Your project's blown. It will go more than 30% over time or budget. And that's what, so far as we can tell, seems to happen. In this case, well, for a case of Eastlink, for example, the table was done like this. It was filled up by the 3 boards, and the contractor was asked, "Oh, contractor, we're worried about these things. Could you take these things on board up front?" And the answer to that question is absolutely yes, because we want a good project reputation and we want it to go well the first time. I'm advised that project came in ahead of time and schedule, and they made about $500 million on the thing. This slide here is just making the point about you need to check the geography of what you're talking about. Roads, this was actually done for a water treatment facility, a water treatment organisation to the west of Victoria. They're trying to deliver water to the Shutterfair Class A potable water. They've got various catchments, various reservoirs and things like that. But when you're drawing up a threat and vulnerability table, you've just got to think this through, because a guy with a backhoe is not much trouble on a catchment, but the guy with a backhoe is bad news to your transfer pipes. So you've just got to think through what threats are relevant to what aspects of whatever it is you're looking at. I have always automatically sort of covered this in a sense. You know, we did the generative interviews for EastLink that worked out the critical success outcomes, the credible threats, which gives rise to the vulnerability table. And then the directors did the vulnerability assessment based on criticality. And you seldom do a risk assessment, because if you can get rid of all the credible critical vulnerabilities for $100, why would you bother with a risk assessment? The only time you fret about risk assessments is when you've got major cost solutions, which will cost a lot. You've got two competing alternatives. You don't know one which gives the best best cost benefit arrangement. You're only going to do one or the other, and you say, okay, let's take it away as a separate study and do a separate risk analysis on the options, the risk control options we've got in mind. But for the most part, most of the issues just dealt with at the vulnerability table. There's that criticality characterisation that I sort of described earlier, so I won't go through that again. The calculus of negligence that the lawyers refer to, and which is the one that comes from the common law, case law, and which is basically applied in all these situations, is from this case and the decision by Justice Mason in Warringshire Council versus Shirt. This is the way he's put it. The perception of a reasonable man's response calls for consideration of the magnitude of the risk and the degree of probability of occurrence, along with the expense, a difficult inconvenience of taking alleviating action, and any other conflicting responsibilities which the defendant may have. And the barristers that we work with always direct our attention to it, and we always use it, and everybody seems to be happy with that. One point I would make about it all, and this is just something the way with our legal system works, that reasonable person they talked about there, the reasonable man in their previous decision, this is a figment of legal imagination that the courts use. This is from an American law professor who was published by Oxford University. The reasonable person is not any particular person or an average person. The reasonable person looks before he leaps, never pets a strange dog, waits for the airplane to come to a complete stop at the gate before unbuckling his seatbelt, and otherwise engages in the type of cautious conduct that annoys the rest of us. This excellent but odious character stands like a monument in our courts of justice, vainly appealing to his fellow citizens to order their lives after their own example. Just be aware that if you do wind up in court, it's whatever the reasonable party you're talking about would have done. Is it the reasonable project manager? Is it a reasonable design engineer? Is it a reasonable general manager? It's whatever the reasonable person in the circumstances might be. And that's obviously an artificial construct, but that's just the way the system's done. Now, this point here, we just find it's become, just from a common law viewpoint, if you're talking what constitutes a hierarchy of control when you're acting as an expert witness, as a defence against negligence or acting for or against somebody in a negligence claim, this is the way the courts actually seem to break down the hierarchy of control. The first question is, could it be eliminated? And if you think of the WHS legislation, for example, the two tests are, can you eliminate it? And if you can't, then reduce it. The reduction one is really split into two. Can you prevent it from occurring at all? That's the likelihood side. And if it did happen, can you mitigate the consequences? That just seems to be the three core control places from the point of view of our judiciary when they're considering things and when we're certainly acting as expert witnesses. Now, this one I think Gay was going to talk to.
I am going to talk. I couldn't find my mic button before, so apologies for that, Richard. So how does all this get applied? This is the procurement of the Class A trams in Melbourne that we worked with DOT or PTV with at the time, and we've been given permission to publish this particular example. So very, very early on in the project, R2A was engaged to do the project due diligence review, and again we identified what the project performance critical success outcomes were and the project delivery critical success outcomes. So as you can see, the key one was to enable and enhance service capability, flexibility, and all project aspects, including vehicles, power and depots, had to be a maintainable asset over its design life at the target cost, had to be operationally safe, had to comply with all government policies and in particular disability access requirements, had to have a good project reputation. In terms of project delivery critical success outcomes, they wanted their first tram operational on time, the first 5 trams operational on times, then the first 5 trams proven to be maintainable and reliable on time. That one came about because it was actually a new fleet of rolling stock that hadn't been produced or run in Melbourne before. It was a brand new class of rolling stock, so they wanted to make sure that they could maintain it and it was reliable on the existing network before they went ahead and produced the other 50 or 45 trams. So the 6th tram was then operational on time, had to make sure the reliable fleet was maintained during the rollout, make sure the level of service was maintained during rollout, of course contractor safety, and then the project delivery and budget. In terms of credible threats, we actually went through the project life cycle. So we can consider procurement issues, contract issues, design issues, manufacturing and assembly issues, transportation, commissioning and testing, and operational issues. And this was basically our first cut at the criticality assessment. So that gave the project director and project manager an overall view of what the key credible issues of concern were and where the potential project showstoppers lie by the 3 X's. On the next page, we then did the precautionary review associated with that vulnerability assessment. Now, if you had a look at the vulnerability table on the previous page, there were potentially 481 items on it. If you have the intersection of each of the vulnerabilities, each vulnerability was considered in its own right by critical success outcome and credible threat. However, in a precautionary sense, if you address the actual threat and put the precautions in place to manage that threat, it will manage all of the associated vulnerabilities with that threat. So, for example, delay in the delivery of the approved design, that impacted the first tram being operational, the first 5 trams being operational. So the controls that were put in place address both of those vulnerabilities. This cuts your workload down by an exceptional amount, because what that does is it says that your risk register or issues register, precautionary register, is actually only the length of the number of credible threats that you identify. So in our case, it was 37 items. This became our working document, and we would review this on a periodic basis, either at key milestones of the project or if there were no key milestones coming up every 3 to 6 months, just to make sure. And the question of the group was, the working group was, is this threat still applicable to the project? Yes or no? And that allowed us to get rid of one. So once the procurement issues were dealt with, we took them off our working risk register, but they remained on our high-level vulnerability table. And more importantly, are the controls and precautions that we've got in place still managing that particular threat? Don't get me wrong, no project goes without issue, but there were no surprises on the issue that the project team couldn't manage. One of the interesting things that was asked during the project was the minister asked whether trams could be rolled out quicker, because as they were doing their type testing or their approval and reliability testing, passengers were saying, hold on, you're running a whole lot of new empty trams around on the network, why can't we get on them? And the minister asked, can we roll these out faster? And the project team could go back to the minister and basically say, well, this is one of our critical success outcomes. We haven't quite achieved that yet, but if you want to do that, there's potentially some implications or some consequences associated with that. If we find some issues, we will need to go and retrofit a bigger section of the fleet rather than just the first 5 trams that we find. So the feedback that we got from this particular project, and as Richard said, a number of other projects, was a useful exercise and was able to be rolled out throughout the project.
Probably worth saying that this is about $600 million from memory. And this was the first set of Class E trams. Now, a new class of rolling stock is notorious for going over time and budget. This one came in on time and budget. They were all quite surprised, as far as I can tell. I don't know if you had any views about that, Gay. That's why they let us publish. The next slide is just a slide just talking about if you want to do heat mapping, which a lot of people like to do to characterize risk, you might notice in the previous table there wasn't any, because from the point of view of dealing with showstoppers, why would you bother? Sometimes people like to do these things. What we've discovered is that if you're doing it for projects, projects are normally done on in the likelihood terms, on a per project basis. Some projects go for 6 months or 5 years. And when you're really asking what's the likelihood of this thing happening, you're really asking it for the course of the project. And the other thing we noticed when we're talking to sort of project managers, where bad things have happened and they're sort of sitting on a knife edge to whether they're going to continue a career in this place, which is about the 30% point. It did seem that a semi-log scale for projects seems to make more sense if you're going to do a heat map characterization. It means it's different to the corporate one, which is helpful, because that means you actually do a conscious transfer. Because, you know, if you characterize the risk associated with the project and it's a 5-year project, you've got to do something in translation before you put it into your corporate risk register, which is normally done on an annualized basis. In that regard, I might just skip the next slide and go to the last one, I think, or the semi-last one, second last one. How do you integrate this kind of process with your corporate risk system? And the answer is it's fairly simple, fairly robust, and fairly straightforward. You see there that the high-level project risk assessment process, which gives rise to basically a workbook in Excel, by the way most people do it, with a vulnerability table on the first page and the register on the second page. That's maintained by the project manager and instantly available to any party anywhere in the project who needs it. If anybody wants to know what's going on, just get that current workbook and have a look at it. Now, practically what happens, though, is because those characterizations done with senior people, particularly with the relevant GM, and once the ones we've worked with is generally be a GM responsible for the asset management projects in the business, some of these issues need to get elevated into the corporate system. So what typically happens is that the potential project showstoppers are reviewed, typically by the project manager and the relevant GM, and between them they agree on which ones are going to get escalated into the corporate risk register so they can get elevated to the board if it needs to. I mean, if it's a project that can actually send the business broke, then the board wants to know how the project's going. Like a big IT project, not unfrequently goes well over budget and doesn't work properly and can kill businesses. So those things get elevated. And if, for example, you had characterized in the semi-log scale for the project, then those things just get converted to the typically log, order of magnitude scale, annualized scale that the corporate risk register uses. Now, the advantage of this is that the amount of work involved here is relatively trivial because, as Gay said, the maximum number of threats in the tram project, I think, was 37. That's high in our experience. Normally about 25 to 30 is what you normally have. And only about 2 or 3 of those ever get elevated into the corporate policy. So you don't have dross around the place. You really are dealing at a top-down, the ones that really cause you the grief, the ones that you must deal with. And if you deal with those ones, showstoppers don't appear. And if there are no showstoppers, it tends to come in on time and budget to spec. The last slide basically is just summarising all this thing again. And it's really just a pretty straightforward, from our point of view, SFAIRP type due diligence process. You need a completeness check. You need an argument to establish all the credible critical issues, especially using, in our experience, top-down threat and vulnerability tables. It's very much a military intelligence type approach. For each one of those high-level critical, potentially show-stopping vulnerabilities, you identify all practical precautions, typically by threat, in a issues precaution register. And then you work out the reasonableness in those circumstances, the things you're going to do, and that's where that SFAIRP disproportionality comes in. I'm not sure Gay actually approves the term, but it's actually sort of a chunky risk change. You know, we put this option and we get a big, nice change in what's going on. So we like that big change. Little changes don't help top down. You want a big, chunky change. And then obviously you need implementation of an appropriate review system, and as required, heat map reporting if you want to, but we don't think it's actually particularly important. But if somebody's, and in the case of Victoria, for example, the VMIA, still seems to be, and the government still seems to be welded to following ISO 31000 using heat maps. Well, you do it at the end just to satisfy them, but you don't start with that because it won't land you in a good place. Just as a passing point, we've done this a lot of times for TMR in Queensland, and up there, you know, with 3Xs was a potential showstopper which would damage the project. But if it was big enough project, it was going to cause enough pain and attack the minister, they used to make it a 4X moment, particularly for Queensland.
All right. Thanks, Richard. That's the end of the formal presentation. So if you've got any questions, pop them in the chat, and Richard and I have got some time to do that. But I guess just in conclusion, critical to Australia's continued growth is the delivery of large infrastructure projects and the procurement of fit-for-purpose plant and equipment in a timely and cost-effective manner. For projects to be successful, I hope we've shown you that they have to be both successful in project performance and project delivery terms. This requires a contextually sound, robust and transparent project governance structure and an effective project risk management process. And these two elements combined together demonstrate project due diligence. R2A have applied this process to a number of very large rolling stock and infrastructure projects, which has proved very successful. It involves keeping everyone's eye on the prize and ensuring no one loses sight of the overall objectives of the project. The SFAIRP approach can be used to positively demonstrate due diligence for the critical rare potential project showstoppers, which are the issues of greatest concern and difficulty for senior decision makers. We've also found that the process ensures the organisation has confidence in the project risk management process and ensures that the project is right the first time, resulting in successful outcomes. So still no questions in the chat box, so that's okay. So we'll wind it up. Thank you for joining us today. We hope you found it interesting. This is our last webinar for this year, but we'll continue to run another free webinar series next year. So if you've got any topics that you might like to hear about, drop Richard or I a line, and we're certainly happy to consider those. There's currently a chapter in the larger R2A textbook on project due diligence that contains all the information that Richard went through today. And we're currently working on a little booklet around this topic due for release early next year. So like always, our current publications are available for purchase through our website, and details will be sent through in the recording. So that wraps up our webinar for today. Thank you again for joining us. Have a great afternoon. We hope to see you for our series of webinars next year. Thanks, everyone.
Thanks. Bye.